So for this, you should have picked up your graph scenarios paper as well as your 1.5 analyzing patterns and ecosystems. Please make sure you put your first and last name on it. And so what we're going to end up doing is it says, read each of the 6 scenarios described below. Each one describes an interaction between a population and an abiotic or biotic factor. Fill in the graph letters for each scenario. Hint, mark in the story the parts that are biotic or abiotic. Then explain your thought process, matching the graph in the scenario such as any patterns you noticed. If the interaction is biotic, explain what pattern of interaction is occurring. Is it predation, such as predator-prey, competition, mutualism, commensalism, or parasitism? We do need to use restated sentences as well as capital letters and punctuation. So first off, after you've put your name on that paper, we're going to analyze what is happening in here, kind of like what we've been doing. I'm going to use 2 different colors. I would suggest the same thing just so you don't have a bunch of things get a little bit confusing. And so if I'm looking at, we'll just say graph C. All right, well, your population 1, it looks like it goes down and then up, down, up, down, up, down, up, down, up, and then it keeps going down. And then if we're looking at population 2, looks like it starts to increase. I'm using my different color. And then again increasing, then it decreases, increase, decrease, increase, decrease, increase. And you're going to do these for each situation. So for example, now I'm going on to graph B, and these aren't in any particular order. The only reason they're laid out like this is so that the graphs matched as far as room-wise on the paper. So you're going to go ahead and mark what you notice occurring using those 2 different colors for your 2 different populations so that when you start analyzing them, it'll be easier to see. You can see how it kind of gets a little funky. So you're going to pause this video now, and then in a couple minutes check to see if you got yours set up correctly. All right, now here you should have been able to see if yours looks similar. If you have different colors, that's fine. And then you can pause this. If you don't have equal signs and you just drew the arrow around, that's fine too. So what we're going to do is, now that you've got this marked, we've got our scenario. So we're going to first read it and see if we can figure out what parts are biotic, abiotic, that whole bit. So it says, rainbow smelt are a freshwater fish that can survive in a wide range of lake environments. When the rainbow smelt were introduced to Crystal Lake in northern Wisconsin, they quickly changed ecological interactions in the lake. For example, they ate up much of the food preferred by the other fish. They have nearly eliminated the yellow perch, another type of fish. So if I'm trying to walk myself through it, I know that one of the populations described is rainbow smelt. The other thing they're mainly talking about is the yellow perch. And so I know that rainbow smelt is biotic, and I know yellow perch is a fish also, so it's biotic because it's been alive or came from something that was alive. So automatically, if I'm looking at my graphs, if I've got a biotic relationship, that's going to involve 2 populations. So I know it can't be graph F. I also know it cannot be graph A or graph D. So I'm not even going to look at those 3. So now that I know it's between the rainbow smelt and the yellow perch, if I'm looking back at it, it says that the rainbow smelt were introduced into this lake. So we know that the yellow perch were the original population, and they were doing fine until the rainbow smelt came in. So if I'm looking at these 3 graphs, I would probably see if the yellow perch were fine, they might increase, they're probably staying about the same, increase, decrease, that sort of thing. But then all of a sudden they sharply decrease because this rainbow smelt was introduced. Well, if I'm looking at population or graph C, okay, so this could be my yellow perch, And then maybe this is when the rainbow smelt were introduced, which caused the yellow perch to decrease. Okay. This is more of a predator-prey where one goes up, the other goes down. If it says that they nearly eliminated the yellow perch, that one can't be it. Okay, so let's look at population 1. All right, population 2 could be my yellow perch coming in, but the key word is it says that they have nearly eliminated. Eliminated means to go down to almost 0, if not 0. Graph E does not show that population 1 is going down to 0, so it can't be E, so it's got to be letter C. So I'm going to write letter C, and then if I'm if I'm writing this, I could say graph C shows scenario 1, and then it says that I have to explain it. So we could say the yellow perch population decreased when the rainbow smelt were introduced. And we could say the yellow perch were nearly eliminated. So that means they almost went down to 0. So they were nearly eliminated, I'm going to say, because of the rainbow smelt. And so if we know that they were nearly eliminated because of the rainbow smelt, so that must mean that they're both trying to get the same thing. So we could say this is an example of competition. And remember, you're only writing what type of relationship if it's biotic, meaning if it's population. And you're going to do the same thing for the other 5.